Hello everyone. Thanks for joining me here for my talk titled Enhancing GenAI with Rust, Leveraging Safety and Performance for Scalable AI Systems. This talk is based on my own personal views and hopefully adds value to you. In this talk, we'll cover Introduction to GenAI. In that, we'll touch upon building blocks of GenAI. Then we'll move over to Introduction to Rust. We'll explore core features of Rust. We'll further see some of the challenges in today's AI applications and why Rust could be a good fit for those applications. We will explore one or two case study and then we'll move on to the current state of Rust with the current overview, ecosystem, and how it blends with the AI. We'll discuss future prospects and conclude. Let's ask ourselves, what do we mean by Gen AI? Gen AI or generative artificial intelligence is a subset of deep learning that employs training on supervised, semi-supervised, or even unsupervised learnings. It differs from the traditional discriminative AI in the manner it operates. That is, it creates new content based on the data it was trained on. In simple terms, Gen AI is a kind of AI that can produce output in multiple formats like text, audio, images, and even animations. This is a huge leap from being able to just pattern match, recommend, identify the objects. Gen AI has emerged as a transformative technology enabling machines to create advanced, context-aware outputs across various domains. Some of the popular examples are DALL-E, ChatGPT, Gemini, Firefly, and many more. Now let's discuss the building blocks of Gen AI. Gen AI is made up of several components, including foundation models, inference code, data pipelines, and libraries. Let's discuss one at a time. FMs or foundational models is an AI neural network trained on huge raw data, generally with unsupervised learning, which can be adapted to accomplish a broad range of tasks. It could range from singular to multimodal in nature, meaning it can interact from text to text or text to audio or any other combination. Examples are BERT, GPT, CLIP, etc. LLMs, subset of foundational models, also known as large language models, specifically trained on a large natural language dataset. LLMs are specifically designed for processing and generating human language-based data. Examples would be Meta's Llamas, GPT, BERT, Google's Gemini, and they are mostly general-purpose models. We also have domain-specific models, for example, vision, finance, health, etc. Those are trained for specific domains use cases. They have tuned parameters as per the requirements, and they're better suited for advanced use cases. One of the examples that comes to my mind is Florence. It's a foundational model for computer vision. The next component in Gen AI is inference code. Inference code is bridge between generative model and applications. It handles interaction with trained models. It manages input processing, encoding, decoding, and managing the generation process. This component ensures that the users of the applications can effectively communicate with the generative AI model. The next component is data pipelines. Depending upon the application, generative AI systems may require complex data pipelines for pre-processing input data or formatting the output data. These pipelines ensure that the input data is correctly formatted for the model and the generated outputs are in desired format. The other component is APIs or libraries. So APIs are used to send the data whenever there is a request, for example, the text prompts or image conditions, and they receive generated outputs, for example, generated text, images in response. Libraries, wrappers, or web layer are a crucial component of Gen AI. Now, most of these building blocks are also available as a service to consume. starting from foundational models like Llama or GPT or Gemini to services like Vertex AI, Studio, Agent Builder to consume those models. We also have services like SageMaker or Model Garden, which makes it easy to create, share, tune, test, and even deploy new models. We also see available APIs which are connected to these deployed models like speech to text or vision AI. These are numerous no code or low code Gen AI studios for building end to end applications using goodness of Gen AI models. Now that we have covered Gen AI and the basic blocks of Gen AI, let's move to the Rust. Rust is a multi paradigm programming language focused on safety and performance. It's designed to be systems programming language competing with C++, Go in the areas like operating system, game engines, and high performance applications. Rust achieves memory safety without garbage collection, and its rich type system and ownership model prevent many common bugs found in other languages. Some of the history behind Rust, I'm pretty sure most of you already know, is that it was initiated at Mozilla Research in 2006, and the first stable launch was in 2015. It has come a long way since then. It is primarily known for its concurrency, performance, memory efficiency, and safety. It has been adopted by big companies like Dropbox, AWS, Yelp, Meta. As per some survey, there is about 3 million coders which are using Rust on daily basis. I again stress that Rust is a best suited language for performance critical applications, be it embedded, IoT, or even internet scale applications. Now let's check the core features of Rust. The first feature, that is, it's amazingly fast. It is also suited for concurrency. It ensures type safety and it's very efficient. Let's dig deep in some of those features. Why Rust is fast? Rust is fast because it uses LLVM to generate assembly code, which is a state-of-art optimizer comparable to best-in-class C and C++ compilers. It makes easy to lay out data structure in cache-efficient manner. Its type system lets you choose pointer or reference strategy that does least amount of work at runtime while still being safe. Rust is an ideal language for writing concurrent programs because it was designed with concurrency in mind. Rust ownership and borrowing system ensures safe and efficient memory management, preventing data races and other concurrency bugs. This system allows many developers to write concurrent code with confidence, knowing that the compiler catches many common errors before they become bugs. Safety. As we touched upon safety in concurrency already, Rust borrower checks ensure memory safety without overhead of garbage collections. This means fewer memory leaks and crashes. How it is so good in performance? Because Rust provides fine-grained control of memory and the resources over C or C++. It has other benefits such as modern tooling. With Cargo, Rust Package Manager, and Build System, Rust is highly praised for its ease of use. Rust also has a vibrant and growing community, which results in good documentation, community support, and expanding ecosystem. Let's move on to some challenges in today's AI applications. There are a lot of challenges, but we are specifically talking about technical challenges in building or running AI application. A lot of it stems from memory leaks, handling huge data, having super low latency, performance barrier, and also the computational resource crunch. The integrations are also one other challenge with which is currently prevailing in AI world. So let's talk about few of those. What is memory safety in AI world? So generative AI models, especially large neural network, can consume vast amounts of memory. This becomes a prevailing challenge in AI world. The next is concurrency. Tasks with generative AI, such as data preprocessing, training, or running inference across multiple inputs simultaneously, needs safe concurrency. Moving on to performance, real-time content generation, which is the core of genai, requires low latency along with heavy computation, leading to critical performance thresholds in genai applications. In nutshell, genai challenges are speed, safety, scalability, and efficiency. Now, why Rust in AI application? Because we have seen the challenges in AI applications, starting from writing a foundational model, using them, or even writing the applications to the core features of Rust. I think there is a mapping of these two groups. Rust is known for its memory efficiency and safety, whereas one of the challenges there is in AI world is memory leaks. Rust is known to be very fast, whereas the new AI applications would require low latency and they demand critical performances. So I think the marriage of these two is definitely very useful. Let's dig deep in those. Benefits of using Rust in GenAI. Speed. Rust compilation to machine code allows it to execute faster than languages that rely on interpreter or virtual machines like Python. This speed is beneficial when working with large-scale Gen AI models or when deploying these models in production, where efficiency and quick response times are critical. Moving on to safety. Rust strict compile time checks help prevent common bugs such as null pointer, differencing, buffer overflows, and data races. In context of AI, where models often process vast amount of data, ensuring memory safety is crucial to maintain system stability and integrity. There are other benefits also which are less talked. For example, interoperability. Rust can interoperate with other languages such as C or Python, allowing developers to integrate Rust components into existing AI pipelines. This makes it possible to incrementally adopt Rust for performance critical parts of the system without needing to rewrite entire projects. Rust portability also allows developers to write code that runs efficiently on different platforms, including embedded systems. This is particularly useful for deploying AI models on edge services, where resources are limited. Let's talk about the case study Polaris. This case study is basically to tell that how a data analysis library, Polaris, is better than some of the competitors like Pandas or Modin. So Polaris is written in Rust. It's highly performant and it has been benchmarked around 30x performance against Pandas, which is written in Python. Moving on to the current state of Rust. In this, we will discuss about how Rust is operating right now with respect to AI. Now, Rust is popular and established in the mainstream engineering projects already, like Firefox, Dropbox FileSync, Meta's Monocoque, Cloudflare's FileWar products, Discord's Plurple, Redux OS, and the list goes on. So Rust ecosystem for applications is strongly emerging, but it's still maturing. There are few opportunities today with respect to Rust and AI. First being ecosystem maturity. The ecosystem is growing and has come a long way, but still it is not mature. There is a steep learning curve with Rust language itself, which is an opportunity today for us to improve. The community is vibrant, but it is still lacking few things. The tooling is next part which we can improve. Let's move on to more details of existing ecosystem and what are few of the libraries and frameworks which are present there to enable Gen AI use cases. There are endless list of bindings which exist today if you compare with few years back. For example, PyTorch, TensorFlow, even Hugging Face Tokenizer. Those bindings provide capabilities comparable from different languages in Rust today. One of the things which has really taken off is Lympha. It's a machine learning library in Rust focused on classical machine learning algorithms. This has proven to be highly performant compared to their other languages and versions. Burn is a newer, deeper learning language that leverages Rust for performance and safety guarantees. And then there is also integration with other languages using some libraries like PyO3 for Python and plus is using FFI. There are several new libraries for use cases dedicated to image processing, data framing, NLP, graphic modeling, and these are coming on daily basis. Despite the challenges that we discussed, Rust is still being adopted in various aspects of AI development, starting from model deployment to AI libraries to edge AIs and even the AI application itself. Rust is being used in deploying machine learning models due to its performance and safety features. Projects like 10gram allow developers to train models in other languages and then deploy using Rust. AI libraries, for example, AI and machine learning libraries are emerging in Rust. Libraries like Lympha aim to provide a comprehensive toolkit for machine learning in Rust. And then we already covered integration with Python using PyO3 and Rust C Python, where developers can still write their code in Python or other languages and then use these libraries for bindings. Edge AI. Rust is being explored for deploying AI models on edge devices where performance is critical. And the next is AI apps. AI apps are on the rise, be it real-time, embedded, IoT, or even research. The one thing common coming out of AI apps are low latency and large scale of computation or large scale of the scope. And this is the area where Rust will see most of the impact. Talking about future prospects, AI apps are going to be near real time and more computational and scalable. While Rust has steep learning curve, but it does fit the bill in every other aspect, from safety to concurrency to performance. Rust can fit in any stack in the genai building blocks, be it foundation models, deployments, libraries, or even services or applications. Rust is going to be seen in more embedded IoT large traffic applications along with research and experimentational use cases, just like Google's deduplication library. Since Rust is not yet mainstream for AI, this presents the opportunity for growth and adoption. Community support and tooling needs to be more mature to support this growth. In conclusion, I would like to recap that Rust core features enable it to be explored and adopted in GenAI space. Its main characteristics such as safety, speed, performance, interoperability, cross-platform development, and performance optimization makes it apt for AI use cases. There are cases like real-time applications, IoT embedded system, and large-scale application where Rust could give the best ROI. There is need to be mature our tooling, community support, which will speedify the adoption of Rust in AI space. There is more upside and growth opportunities with the winning combination of GenAI and Rust. And with that, thank you so much for your time and hopefully you liked the presentation.